Hello, my name is Rahul Karn. Today I am excited to present my project for the information retrieval assignment. I have built a complete system that includes a web crawler, a vertical search engine, and a document classifier, all accessible through a web application. In this video, I will walk you through the project's code structure and then give you a live demo of the final application. Let's get started. The entire project is built in Python and is organized into main app directory. Let's begin with the first component, the crawler. The crawler's job is to ethically scrape publication data from the Coventry University Pure portal. Run selenium.py. This is the main script that starts the crawling process. It orchestrates the entire operation. Config.py. This file holds the configuration like the starting URL and the path to save the data, making it easy to manage. Robots.py. The important part of ethical crawling is respecting the website rules. This module reads the robot.txt file to ensure we are allowed to scrape the specified pages. Browser.py. This sets up and manages the Selenium web drive, which is the automated browser we use for scraping. Listing.py and detail.py. These fields handle the code scraping logic. Listing.py navigates through the main publication list page, while detail.py goes in each publication specified page to extract key information like the title, authors, date, abstract. The scraped data is then saved into .json file in the data directory. Let's move on to part 2, the search engine. Once we have the data, we need to index it for fast and effective searching. Indexer.py. This script is the heart of the search engine. It reads the crawl data and builds an inverted index. This index maps words to the documents they appear in, which is crucial for quick lookups. It calculates TF-IDF score during this process. Text.py. File contains text preprocessing function. It handles tasks like tokenization, removing stop words, and applying stemming or lemmatization to normalize the text before indexing. Engine.py. This is where the search logic lives. It takes user's query, processes it, and uses inverted index to find and rank documents. It implements ranking, uses both TF-IDF with cosine similarity and the more advanced BM25 algorithm. It also includes a neural ranking step using a cross encoder to improve the relevance of the top result. CLI.py. This provides a command line interface to build the index and run the test searches directly from the terminal. The final component of the backend is document classifier. This module is designed to classify news articles into one of three categories: business, health, or politics. Data.py. This script is responsible for loading the text files from our dataset, which organized into folder by category. Tokenizer.py and vectorizer.py. This handles the feature extraction. Tokenizer cleans the text, and vectorizer uses the TF-IDF technique to convert the text into numerical vectors that our machine learning models can understand. Models.py. Here, I have defined the machine learning model I have experimented with, including multinomial naive Bayes, logistic regression, and linear SVM, all wrapped in scikit-learn pipelines. CLI.py. This is powerful training script. It automates the process of training the different models, evaluating them using cross-validation, finding the best one based on the F1 score, and saving the winning model to a file using joblib. Code.py. This generates the performance reports like the classification reports and the confusion matrix. The web application. Now let's see how all these pieces are connected and served to users. Main.py. This script uses Fast API framework to create the web server. It defines the API endpoint like search, classify. When a user makes a request from the browser, it file calls appropriate function from our search engine or classifier to get the result. And our front-end part is index.html. This is user interface. It is a single HTML file with some JavaScript that creates the home page, the search tab, and the classification tab. The JavaScript sends requests to our Fast API backend and dynamically displays the result without needing to reload the page. Great, now that we have the code, let's run the application and see it in action. Here is our home page of the application. It's clean and simple with two main tags. Let's start with tag 1, the vertical search engine. Before performing a search, the system can display all the documents that were crawled and indexed from the pure portal. As you can see, it lists the title, authors, date, and abstract for each publication. Now let's search from the specific. I will type in financial accounting. Search engine processes the query, ranks the document using cosine similarities and the neural re-ranker, and displays the most relevant result at top. Each result has a link that would take you to the original publication page. Now let's move to task 2. Here we can input any text and the pre-trained model will predict its category. I have sentence here. As you can see, the model correctly predicts the category as health. This model is confident in its prediction. Complete overview of my project, from the polite crawler that gathers data to the efficient search engine that ranks it, and finally to the robust classifier that categorizes text. This system is modular, effective, and demonstrates key principle of information retrieval. Thank you very much for watching.